Merhaba tekrardan herkese. Bugün Dirençli Doğal Yapılar Webinar serimizin sonuna geldik. Sonuncusuna geldik. Bundan sonra da yani çok öğretici bir seri oldu. Eminim katılan herkes aynı düşüncededir hepimiz için. Büyük ihtimalle Eylül ayı içinde bir değerlendirme webinarı yapmak istiyoruz. Mümkün mertebe konunun paydaşlarını da bir araya getirecek. Bütün bu seride öğrendiklerimizi biraz özetleyerek bunları değerlendireceğimiz bir webinar da yapacağız sonunda. Bugün konuğumuz Jean-Manuel Perraudin. Kendisi daha çok Yığma Taş yapım sistemi olarak çevirdik. Structural Massive Stone başlıklı sunumunu yapacak. Bu strüktürel imkanları bize anlatacağı sunumunu yapacak. Kendisinden çok kısaca tekrar bir bahsedeyim. Sosyal medya hesabımıza da yazmıştık. Kendisinin inşaat yaklaşımı hem yenilikçi yöntemleri içeriyor, hem ekolojik ayak izine dair, yerine aidiyete dair, iklim ve filtreye dair birçok dikkat içeriyor. Bu sayede taş yığma yapım sistemine odaklı klasik ve avantgardın bir arada olmasını sağlayabilen yaklaşımı ile sürdürülebilir ve deneysel mimarlığa öncülük ediyor. Kendisi ENSA Paris L'Atelier Üniversitesi Mimarlık Bölümünde 2014'te mezun olduktan sonra Jourda Architects ile çalıştı. 2017'de de Gilles Perraudin ile birlikte L'Atelier Architecture Perrauding'i yani mimarlık atölyesini kurdu ve hala burada çalışmalarına devam ediyor. Ben sözü moderatörümüz Matthieu Pedergnan'ın bırakıyorum.
Teşekkür ederim Merve. Ben İngilizce olarak devam edeceğim. So Merve has introduced you and told a little bit about your parcours, Jean-Manuel. Thanks a lot for being here with us tonight and speaking about your work inside Atelier Perraudin. We are really happy to host you tonight, especially about this content of structural massive stone that is very important for us as a natural material, because in Turkey, when we speak about natural material, we often forget to speak about stone, even if it is one of the most used natural material as a traditional construction in Turkey, but it's so much not used as a modern construction material except for cladding that we forget that is existing. So we are really happy for you to be here, and that we hope that you will show us what is really possible to do with massive stone as a contemporary architecture. So thanks a lot to be here with us.
Thank you. We forgot all around the world how to build in massive stone. Egyptian maybe forgot too, so don't be. So it's not really weird. We rediscover stone for the reconstruction after the World War II with a great architect, Fernand Pouillon, and then with my partner and father, Gilles Perraudin. So I will try to speak in English, it's better. But sorry, I'm French, my English is not really good. I hope I'm a better architect than a speaker, an English speaker, but I will do my best. So I'm the partner with Gilles Perraudin in the Atelier Architecture Perraudinghi. We are a small office who is based in three basements in Lyon. It is an administrative office. A second one in Breuvert. I will explain why Breuvert. And the last one, it is in Senegal. In Ndangan, in the south of Dakar. It's something like a workshop or something like we want to make a new Taliesin, something between a workshop and a office, something like that, to work about Earth. But it is not this webinar, I will maybe discuss about that. It is, I think, built with our hands, a great part of the architecture, and we have to know how to build by myself before to describe something. We build with so many materials. Maybe you can recognize the Académie Monseni. It is a really big center for students in Germany. It is in wood and glass. We build with fiber in Senegal, earth, and stone naturally. After the office, we have a second part of our work. It is with an association, L'Académie de la Pierre, Academy of Stone, to speak and try to write something, make exposition about stone construction. And we have write a book in English, so you can find it in every good library. To try to describe how we build in massive stone, because you have different way to build in massive stone. So you have some sketch. But the first question is why we build in stone. It is not because it is a beautiful material. It is for two principal qualities. The first quality is it is a natural material. So we try to don't use concrete to preserve environment because the concrete use, of course, energy, but sand and water and every rare materials. And the second, it is because it is an FC material. Because the first building of our office was our building. It is our winery because we make some wine sometimes in the south of France, in Vauvert. And we try to search materials healthy without any chemical emission. And you don't have a lot of materials because wood, you have some treatments in the woods. Concrete, don't speak about that. And stone was a very good materials to winery, and for the inertia, of course, because we are in the south of France, it is really warm, and we need something to keep the coldest for the wine. But if we do it for wine, why we don't do it for children, for school? I think it is more important to use good materials for children than wine, but I really like wine too. So this is our first building built by Gilles Perraudin. You can see him on the pictures. So we do it by ourselves. It is something because you have to convince to try and to test the materials. And so you don't have the project and nobody trusts you with a massive stone. So you try by yourself. And so that's why we did for our winery in 1984. And I will speak about that later, but we rediscover our work. When you build in stone, you do the economic, you do the structure, you do the aesthetical, you do everything. You don't have any engineering to draw by themselves. You are the master of the construction, and that it is a really important. So I will make a short introduction to describe what is stone, what is a quarry, because you can't understand massive stone, structural massive stone, if you don't know what is a quarry, what is a block of stone, how to you get it, because it is the start of our work. You don't build with very stiff stone and soft stone. It is not the same, and the extraction is very different too. I will explain you different projects, and every project depends of this stone. So you have to know that. And I know in Turkey you have a lot of stone, so maybe some people can explain me what kind of stone. But I think you have a limestone, stiff stone, every stone, I think. So you have two types of quarry. You have the underground quarry. This one is very beautiful. It is in the south of France, dans le Luberon. On appelle les quarts de lumière. It is a really big quarry. They don't work anymore, but it is very beautiful. The problem of underground quarry, you know that you have a tunnel. You have just a way to extract. You don't have the capacity to extract a lot, but you have also outdoor quarry. This is the cheapest one, because I don't say that, but we use stone because it's cheap. Use massive stone is cheap. We build social housing. We build every program with stone and with the same budget than if we build in concrete. And that point is really important too. So you have the quarry, and how works the quarry? You have a rail, and on this rail you have a chainsaw, like a block of sugar. Then you cut on vertical and you cut on the other way, and just you extract it. And that's enough. You have your block to build. Then you have saw to cut it at the dimension you want with a big saw. Or a chain, but the chain, the problem of these tools is you lost a lot of stone because you have a particular cut, and if you have a lot of lost, it's more expensive. It's logical. Then you have a block on, I don't know the word, the palette. Don't know, sorry. You put just a block on the quarry, then you move it on truck. Then you get it with just in pince, pardon. And you just put it another block. And you can build a very large building with just this simple operation. I will show you. You can also do other things. We build with structural massive stone arc. It is not aesthetical. I will explain why. But like Luis can said, you have to hear and then ask and hear what material says. Structural brick and structural stone have actually the same language. If you want a large one, you don't have a lot of solution. It is the arc or the flat arc. So you have, this is a social housing. In France, we built it for, I like to say the price because it is very important in France, but I think in Turkey too. it is 1,000 euros per meter square. So it is all in stone, interior like exterior, and with woods and something like that. And it is a really natural and dry building. And for that, every workers and who build this housing, this residential building, was very happy. And with this simple, I say simple, but simple is not easy. Don't confuse. We built a lot of different type of building. We built. This is a college. This is a winery. This is a museum, and this is a social building. But for this webinar, we talk about typical way to build is to build in a square area. How to build in stone in a square area? So we build around 5 buildings. I'm not a specialist. I'm just an architect. I'm not an engineer. But I built around 5 buildings in a square area, and we developed methodological architecture to build without concrete, because it is our purpose. Why we don't build in concrete? We can speak about that. Because concrete is not the best way to build in a square area. Because when you have a square, if you concrete building can stay correctly, you have some micro damage on the building, and if you have micro damage, the steel can explode, and so normally, if you have an earthquake on concrete, you have to destroy it and rebuild it, because you have fragilized the buildings. But stone is completely different. It is not. It is a masonry building, but it is not a stiff building. It is more than a flexible building. You work like not soft, but flexible. When we build in stone, we have more affinity with a wood engineer than concrete engineer, because the building can move. It's not the rigidity who makes the solution. So the first building we did, it is in Voiron. It is zone seismic 4. I don't know the classification in Turkey, sorry. But we work with the Euro code 8. I don't know if you work with that. It is a rules to build. And we say why rules is completely stupid, because the rules is sometimes against the good architecture and the good way to build. I will explain you why. So this building, it is an office building with the basement in stone, and the first floor. The other floor is in wood, massive wood. We don't use kailash or other industrial materials. We try to use massive wood. But this is our first building in our building, where you have other one I'm explaining in a square area. So we did in the typical form shape to answer the rules of earthquake. It is to have an earth in concrete to stabilize, to rigidify the building. And this one, yeah, I think it is not the good way to do it, because you don't use the envelope of the building to have the answer. So you have around 80% of your building you don't use for earthquake. So it is not, I think, the good solution. We did a tower too, but if you speak tower in maybe some people will recognize this building. If you speak about tower in stone, you have to speak about Fernand Pouillon. He built a very large stone tower with a lot of building in stone. You have a lot of earthquake in Alger with the sea, the wind sea, salt winds, and the building didn't move. So if Fernand Pouillon did that, why not me? So we begin with this question. So we lost this competition. We had the second prize. The first prize was for La Caton-Vassal. We did the first part of glass, the second part of glass, La Caton-Vassal. They said this building was too urban. Don't know what to say, what they mean. And this one, that was the same solution. We have a big earth of the building in concrete, and then you try to take all the strength on the earth to rigidify that. I think it is not the good solution too, because you try with duality. It is I told you the stiff of concrete and the flexible of stone. So you have something don't work. I say when I say structural massive stone, you have never concrete in my stone. I never have concrete in. You have the plan, but I will speak with you. I think a long time about this project. We are in Switzerland. We win this international competition of 2 or 4 buildings in stone. A big building, or not a big building, but 8 level, 9 level is enough to build in an area zone. We are in the Alps, and without concrete. How we did that? So the first in Switzerland, when you win a competition, you don't win with the engineer. You win as an architectural project, and then they choose the engineer. The first engineer was not stupid, but try to have some basement and caoutchouc like tower in Tokyo. We say no, it's just a small building. So we win this building. That was a different kind of stone. That was nice it is a very stiff stone, like around 180 MPa of compression. So it's really better than concrete. And de la molasse de Berne, it is another stone, and we try to build with, we are in Switzerland, and we try to build with Swiss stone, but that was a stupid idea. Because why? Because we are near Geneva, and Geneva, I'm sorry if you have some Swiss in this webinar, but Geneva is just a part of Swiss in France. So the area of Geneva is the France. It is not logical to research Swiss stone. We have these 4 blocks here. We don't in Swiss. You can work the shape of the building. The shape have a lot of discussion with the neighborhood and something like that. So when it is validated, it is enough. You have to be in this shape. So we developed the building. So that was here the first solution, because you have punctual effort, strength, so you can build with a stiff stone. After that, and you have to build with 2 meters, around 3 meters blocks. It is really hard to have it. It is expensive. But if you do that, you have to use stiff stone. But if you work with largest wall, it is natural. You can use a soft stone or softest stone. So we change the building. The aesthetical for us, it is not the point, the principal point. It is not the goal. We just want to build in stone without concrete. So if you have to change the aesthetical of the building, we did it. And we did it for every project of the office. We change and here this is probably what, and sorry for this slide. It is just to speak about the local in France. It is very important, but it is not the good way to think, because for the Swiss, local, it is Le Tessin, but it is really important way, because you have around 500 kilometers on the south of France. I don't know if you can see it. It is around 400 kilometers. So the notion of locality is really weird, and that for me it is only the carbon print count. And if you transport it by boat, it is better than it is nearest, but by truck. So I talk a lot about Baalbek in Lebanon. It is built with the stone of the south of Egypt, with the granite of Aswan, with the Nile, Mediterranean Sea, Liban Mounds, anti-Liban Mounds, and you have no print carbon, but it is not near. So the locality, it is really, well, it is not the point of this webinar, but it's very important. So we have the engineer, and so we show the project to an engineer. His name is Mr. Lesouzi. It is a really good engineer. And we won the project with only stone and wood for the floor. And he said, we say, oh, you don't have any problem with that. We don't want to put concrete in the building. He said, no. This is the good way to think, because stone, it is a flexible structure. So it works really good with wood floor. If you put a concrete floor, you will put some rigidity in the project. So it is not the good way. A stone building work like, I don't know if you saw that, it's really impressive. It is a Japanese pavilion, Japanese house who move something like that and just get his elastic form after a big earthquake. And stone work like that. So we continue. What is really important when you build in earthquake area, but it is not particularly in stone, it is the conception of the building, because you have to work with symmetry, to work with vertical alignment of the window, for the strengths to have easily captured by the floor. And that for concrete, stone, wood, earth, and everything. So, but in stone, it is really more important for us, because we don't want to have some solution with really big beams in concrete or something like that. If you want to get to stay with the purity of stone, you have to have the purity of the conception. So you have the purity of the plan too. The plan is very simple. You have the first wall exterior in stone, a second floor in interior, and a third one in stone too interior. So for concrete, it is perfect, because you don't have any direction of the strength. If you have an earthquake, you can take it in this way, or X, Y, or Z. It is not a problem. When we build in stone, of course, we did the stone layout. This was a big part of the job. You draw every blocks of stone. We draw around 4,000 blocks. Some blocks are similar, but you try to do it similar, because you don't want to draw 4,000 block difference. But you have to draw it. You write on each block. Plateau is M for the quality of stone. It is a mini stone. F for the floor of the stone, and 190, it is just a la longueur. So SketchUp is a good way to draw this building. You can't draw massive stone with Revit or Archicad. It's really hard, because you don't have the conception of a linear wall when you just put some window in. It is the structural and the stone, the block, who builds the building. So the way to think, it's better with SketchUp and draw by the end on your brain than Revit or Archicad. But sorry, my brother is architect too, and he is Autodesk elite and work for Revit, but this is my thing. And so you can see you just have the floor put on the stone. This is the draw of the office. We draw everything, and nothing else. And it is an energy building. It is like passive house, and we had a big problem because you have to put your floor on the exterior wall, but you don't have to put your floor on the exterior wall because you have to put some insulation. So it is something really weird. So we have something really simple. With don't know the word of this part in English, but it is very simple. You have, and it is very stupid because you have something a big building in stone, but you have some un PUA, un polyuréthane en isolation en 40-30 cm. Sorry, 30 cm polyurethane for the building, but you try to do an ecological building. So, well, it is a weird way to think. This is the prototype. Well, it is very simple. And this is the detail. It is simple, but not easy. You have around, we have a geologue. Sorry, I don't know the word in English. A geologue. We have
geologist.
A geologist for the building. You have around 3 different structural engineers. You know, very complex team for this building, just to put a block on another block, on another block. So it is simple, but not easy. And this is, so the building, the build, the office who built this was Marty. He never put a massive block. Gilles Perraudin, like say massive stone block, it is like prefabrical concrete, but he say it is a natural prefabrical concrete. So the masonry say, oh, okay, it's easy, you just put a block on another block. So Marty did it. So you see every block here. You just, I don't know the word for that too. It is a word for, sorry, you see my mouse.
A crane.
A crane, sorry. You have just 2 cranes to put every block on each one. And you build the building like that. Each block has the interpretation. You get it. And this is the building at the end without the exterior. This is very simple. Just when we rediscover stone, we rediscover what is for us architecture. Architecture is just light, materials, and rhythm. It is not the engineering and something like that. It costs a lot of things. It costs a lot of things for us, for our environment. Architecture is just rhythm, materials, and light. And with that, you can do everything. For us, it's our way to think. This is the building. This is a social building, but in Switzerland, social building is really expensive. But it is the same price of with the other price of the other building in the other area in Switzerland. Every building has the same cost. You can't you can build cheaper than the other one. Every building has the same cost for each meter cube. We don't, not in square, but in cube. That's another way to think. And in stone, the problematic is the detail. The detail of the cornice, the bandeau, here to stop the water. This one I was draw with the geologist and us to draw the perfect draw of this element. And you can see the perfect draw of this element is really near than a traditional draw. My philosophy is to think learn from the past to build the future. The problem of modernism is to erase the past, but the past has a lot of things to learn from, I think. We have concrete, of course. We can build everything in stone, but we tried. And for the problem was the area, the local rules. We couldn't build with floor in wood because you have to have a largest teeth of the floor, and we can't because it was too high with floor wood. So we had a big problem with concrete floor. Well, you can see the detail we have. It's really nice in Switzerland because the enterprise, the builder build what you draw, exactly how you draw it. But if you draw it badly, you have it badly, and the responsibility is for you. So, well, yeah. And the interior of the house, of the channel, with, of course, the stone in the building. So you have the inertia of the stone. You don't have to have clear insulation, more insulation, or something like climatisation, or something like that. But like your oldest house of your grandmother, grandfather, who have largest stone wall or earth wall, they wasn't built with this teeth, but of the structure, the teeth of the wall wasn't for the structural, but for the inertia in the traditional wall. So we try to build only with between 60 or 40 centimeters for the walls. If you build with smallest one, you lost the inertia. When you want to have a largest window, you did it with a flat arc. To something really easy, but you can see it in every town. It is you have a lot of books how to build it by better architects. Yeah. I will speak about another building, and it is just a small house.
We cannot hear very well anymore when you are far away from the computer.
Sorry. It's better?
Yeah, it's better like this.
I will speak about just our smallest building of the office. Why? Because it is in stone, of course, stone wood. and an earthquake struck this area 2 years ago. This is just a really bad zone with a really small house around every town of France with concrete and puppy stone. So we built it. But that was a program built a building, an house. Sorry, not a building, an house of 200 square meters and the cost was 160,000 euros. So it's around 800 euros per square meters to build in stone and wood. That was a challenge. We tried. I don't know if we succeed. You will see, but we tried. To do it, we built this building in stone and wood without insulation. We are not on the rules of. In France, you have to put insulation, but the clients say, no, I don't want insulation. I'm in south of France. It's a stupidity. I want inertia in my house. I don't want to cut it with insulation. So we did just an house on 2 floors, 10 meters per 10 meters on 2 floors, so 200 square meters. Well, really simple, with some moucharabier, some not poor detail, but a simple detail, because every detail costs. And of course, build it with every building of our office. Not obsessed with that, but with the regular draw, with the rectangle door and everything like that. Every project is thing like that. But the plan is really simple. You have a square. We make a division of this square. You take some quelques poteaux, pardon, and you have just a floor on this. Try to build it without wall inside, because it is just a small house, and to have the perception of the big house, you have to create some view across the house. And we had just a particular of this building. It is the river is very nearest, and we can build before 180 meters, because the water can go at this level. So we use this constraint to do something. In this first floor was in the shadow of the day. Is used like a chimney. We can see in Iranian, the chimney to ventilation, something like that. So we use every constraint. In France, you have a writer. His name was Georges Perec, Loulipo, who said the constraint is freedom. More you have the constraint, the more you have freedom, because you have something, you have a box, and think in the box is more easier than think out of the box. But we can speak about that. So this is the house, very simple. The client was an artist, but he said, I will not put some pictures on my wall because the wall is the picture. When you have the light, you change on this wall, that you change the spirit of the, say that, I'm more radical, let's say that. The spirit of the house when you are the night or the day, when you have the light of the morning or the light of the evening. So he's an artist, but he never put pictures in. And we try to build, in each project, we try something more. In this one, we build the stair in stone. It's not really art, just a particular layout, but you can do it. And we did the stone layout, like every project, every blocks are drawn. You did it. But in stone, you can do a lot of things. This is not our last building, but this is a particular building with an eye. It is a reference for Lucian, of course. But this eye is not free. We never have a free draw. Every draw is thing because a draw costs, and a draw costs for the structural. And of course, if you draw something in stone, you never follow the stone rules. You have to put some concrete, and then you have some problematic of the construction. So you have to follow the rules, and then just have try something to make something coherent. Why you have an eye here? Just because it is a mixed use building. On the first floor, you have sorry, I don't have the word for une menuiserie.
Window frame.
Window frame on the first floor. The second floor is an office. The third floor is for student housing, and the two last is for just the clients. Okay, you sell it. I don't know. This is not my job. But so you can see the plan, and here you have arch, but an arc. Why arc? It is not aesthetical. It is because it is a window framer. You need an open space to work. If you will not speak for Wiscan, but what wants stone? He wants an arc. So we did an arc, and this arc is on the elevation. That's why you have an arc here, just for that. And this one, maybe free. And the second one is built with stone. And you can see of course, in every project, every wall have to put on the other wall. So when you have a mixed use, you have to make some combination between some different program to put it on the other wall and the other wall. That is the complexity of the building. If I put this chair wall here, that will be a problem for the structural, because you have how many tons of stone on the floor. That's not a good idea. That's the draw. So you can see the arc on each level. This one was an open space, because every office might now work in open space. I really hate that, but it's better to set it. And then you have residential student housing, and then duplex for the clients. Yeah, we liked this view, like because we see the structural, how the structure build our conception, or the conception. You can't. We don't have a skin on the building. The skin, the structure is the same thing. So you have to have the. You have to hear what stones say to you. It's very important. And this one, like, it's very different thing than the other building, because you have a grid here. Why? How we can have a grid on a building of stone? Because my wall is a shear wall. You have to stabilize my building. But we can have a grid because if you see the plan, we have a cross here. So I have a free draw on the main elevation. So every part of the conception is a link. So just a small draw. And here is the building in the way. I will not say it is really easy to. Easy, not simple. No, or simple but not easy. To have a draw, but you have to understand how stone works. Stone works with 2 points: friction and its weight. If you put some concrete in there, the friction, so the movement in the stone doesn't work because you have some concrete in the stone. But also, the movement is blocked, and if you make a void on the stone to put some concrete, you lost the weight. So it's really a bad idea to mix concrete and stone. And I will not say the problematical of when you put some concrete and stone, because you are not the demand dilatation. Dilatation? I don't know the word.
Dilatation, yeah, it's the same.
Dilatation of stone on concrete. So when you have warm the steel of the concrete, we grow more than the stone. So you will explode everything. You can try it, but I will not. It's a beautiful construction. And this is the arc of the window frame. This is the office. Another architectural office take this this floor. Didn't have the money, but it is a beautiful one. And this is the interior of the building. We always try. We always not try. We always put the stone inside, because it is more important inside than the outside. Because when it is a small house and the client is really intelligent, you can't get away the insulation. But when you work with for an administrative client or client bigger, you have to get some insulation. So the stone slows the warm or the cold, but you can't get the inertia. And the answer, you have only that with interior stone. I will not speak about the work of the loggia and something like that. Sinon, I will end at midnight. But it's really important, like structural and the conception of the biochemical draw. Everything is embedded. Just a room. And sometimes here we work with two, maybe you saw that, sorry, different kind of stone, type of stone. Why? It's really stupid, sorry, to have a concrete wall of something like 20 centimeters at the first floor than the last floor. It's stupid. So in stone, like as you are in the economical way, you use a better stone for the first floor than the last floor. It is logical. For this one, we use this stone. It is the Marina stone. It is a Spain stone with something like 150 MPa. And here for this stone, it is only 20 MPa. But here you have the arc, so you need a very stiff stone. This is a way to build with the same largest of the stone. We need 40 centimeters. But in the project of Genève, we work with different kind of eight of stone, of largest of stone. We worked at the basement with 60 centimeters and the last level with something like 40, because it's logical. This one is not a really hard zone for earthquake. We are only on zone 2. We are not on zone 4 like Genève. But I think we work at the same way. What time is it? Sorry, that's the last project. It is a two-build building. So 100 housing, a good building in France. In seismic 4, but in France this time, not in Switzerland, because in Switzerland you don't use the Eurocode 8. In Switzerland they are smart. They are not in the Europe, so they can use every logical rules for earthquake. So they take the good rules because they think 8 degrees earthquake in USA and 8 degrees in France, it is the same earthquake. So you can use every rules you want. But in France, it is very different. You have to use the Eurocode 8. So this is some big building in stone. Big, I don't know, but it is around 4,000 meter cube of stone. That's enough for me. We try another one in France, in Lyon, around 6 meter cube of stone, which is not a problem. You have to have a good organization when you buy it. So I will just explain how work earthquake in France, because we are something like that's why I told you at the beginning, rules are stupid sometimes, not every time, but sometimes. Because this building is 50 kilometers of the project of Genova. It is very near. But I'm not of the same country, so not the same regulation. In Swiss, they do what they want. In France, I do code. So they are code 8 in France. It works in Italy, everywhere in Europe. Work with some, not completely stupid, because that's what you have some rules to build it good. So you have the rules of symmetry and symmetry. Because the square work in different positions, and if you don't want to have more strength of the square on a part of the building, you have to build it symmetry. You have the capacity, of course. More it's compact, more you can take the effort. You have les lancements. Alors, les lancements, si vous avez le mot, je le prends.
Slenderness.
OK. You don't have to, that's why it's stupid to build tower when you are in an earthquake area, I think. Sorry. You have the regularity in elevation. Of course, I told you about that. But it is our way to build, to have the conception. No, so we don't have the problem with that. And we have a really good engineer in France. His name is Paul Roman. It is a big one. He works in Germany, everywhere. And he proved the build work without concrete, because it is clearly the same of the building in Geneva. But the Eurocode said you have to chain the stone. Change the stone. But I go to the control office. I don't know if you have control office in Turkey, but maybe I think. Bureau de contrôle, alors. Bon.
Yeah, engineer office. There's no.
En fait, on a l'ingénieur. We have engineer for ourselves, but after you have another office who control our engineer. Stupid. The engineer say no. The Eurocode 8 say you have to put some concrete, some chain. You have to put some. We say we did it really nasty. No. You have to do that. So I say, I don't want to put some concrete in my stone. And I said, okay, why not? But I write you a paper, and in this paper, I write every problem of the concrete in stone is the responsibility of the control office. He never want to sign that. He say, okay, we will find another solution, something like that. So this is the first building in France. We use the filler conception of the building. It's something like use a bazooka to kill mosquitoes, something like that. But we try to. So we modelize every block. And you can see here. So it make the model in a elastic linear model. And it works at the beginning, it works at the end, but we use that. But he said, bon, the Eurocode, if you want to build it and to have some insurance, you have to put something in your stone. And you're okay, I will put something in my stone. But I don't have the chain, because in chain in France, you have to put some concrete on each door with chain in concrete and something like that, etc. No, I work to have just an achat. An achat in France is something just a thin steel of concrete in my stone, and each floor is attached between them to make a constraint between floor. My stone can't go to the void. I don't know where it can go, but say that. So you have just some steel, but without concrete, because concrete is not a good word. Concrete is not bad. It's armed concrete was not a good idea. You have just a steel between floor attached between them to get the rigidity between floor, but not on the between every blocks. And we begin this building I think next month. So I hope that will be a good idea and not too hard for workers, because they have to make a void on each block, put the steel, attach them between floor. I just want to put a block and another block. It's easier and it's work. But the rules told me you need that. So the rules say something good like symmetry, elevation, regulation, something like that. But they can say you something stupid. So I don't know if you have rules in Turkey like that, but I think the only rules you have to follow is to have a logical building and something not aesthetical. You have to think for the area, not for the rules. Thanks for your attention.
Thanks a lot, Jean-Manuel, for this presentation. It was really complete and with a lot of information on the detail of the construction. So thanks a lot for it. And now I think I have seen in the chat some questions, and one of them was related to if you were using some mortar between the blocks.
Yes, I use mortar, but it is what is the word for à la chaux?
Lime mortar.
Lime mortar. It is not concrete, because when you have an earthquake, it is the joint who takes the strength.
Yes.
The joint who takes the strength. The joint have to be more softer than the blocks. If the joint is stiffer than the blocks will break. So yes, we use mortar, but the mortar is only for the constructor, because it's easier to put and get the level with the mortar. You can put a sec, dry construction, but the quarry have not the perfect sketch. So you have to adjust with mortar. It is the only way, the only reason.
Okay. Thanks a lot. I think Ant has a question also.
Yes, hello. Thank you, Matthieu, and thank you, Jean-Manuel, for your very beautiful presentation. I have 3 questions. The first is, I think it was the 3rd example you did show us. I think it was the 3rd, and it looked like that you used on the floor a rendered floor. So my question is, did you integrate it have you integrated rendered floor systems in your projects?
Not this one, the project in Genova. This one.
Just the beginning, the wooden house with this wooden outside.
Which project?
You have to go back. It was just
detail the third. You say
beginning of your presentation.
This one.
This one. Yes, exactly.
Yes.
So
Yeah.
it looks like it's a rendered floor, but is it really, or what's your opinion about rendered floors to integrate them?
Render floors.
Render.
If it is c'est un sol en pisé. Un sol en terre.
Earth floor.
Earth floor.
No, the problem of the earth, because we use a lot of earth, but not in France, because it is too much expensive materials. Why we use stone in France and not earth? Because the first social housing we built in stone was in earth. This one in Pisé. It is a typical technical in France. But you have to have a lot of workers. And in France, it is the most expensive. In stone, you have no workers. You have maybe 3 workers to build the building. So maybe we could for the building, but we didn't have the money. That's why we didn't use that. Voilà. En plus, pardon, sorry, we are in Voiron. It is in Isère. It is the country of the earth in France. But I don't have the money. That's why I didn't choose it. And that's why we use just in Senegal, in Africa. The paradigm is changed. The materials is cost a lot, but the workers not.
It's cheap.
Yeah.
Yes. Okay. Thank you very much. So, second question. You did show a project with these arches.
Yeah.
And the arches.
Yep.
And there I saw. So I don't know how much you are integrated in that, but I saw wall heatings, not roof heatings. Sorry. I think it was that project.
Okay.
And there if you go back one of the pictures, I saw them.
Inside the building.
Inside the building for the heating system. Yeah, here, this. So
Sorry.
the panels on the roof looked like roof heatings. Or is it something else?
Si les panneaux de plafond, c'est pour le chauffage, ou bien si c'est les panneaux acoustiques?
Non, c'est des panneaux de chauffage rayonnants.
It's a radiation heating system. Yes, on the ceiling.
Okay, that's fine.
But this floor was completely reaménagé. Sorry.
It was totally changed. I mean, renovated.
Changed, yes, but by the architectural office who take this floor. So we are not on the rules of typical office. You have to put something else to make it completely.
Mm-hmm. No, I appreciate this as a good solution, because I'm also working as a building biologist, and so the healthy issue of the heating system, the heating system from the roof is actually a good system. So
I think the best
that's
system,
why it took my attention.
Yeah, but for me, the best system, but it's not the cheapest. It is on the floor, of course, and the floor with a small degrees all around the day, because when you build with earth or stone, you have a big inertia, so you have to warm it constantly to get the inertia on the stone, and don't work with electrical radiator. I think the floor is one of the best. But just to complete my.
So my last question, at the end of your presentation, you talked about the rules, the regulations, and you said, I don't know how it is in Turkey. In Turkey, we have a central system. Everything is controlled from the main city, from Ankara, and the local municipalities don't have anything to say. And that's a problem. So how is it in France? You made a comparison between Switzerland and France, for example. Switzerland is not in the EU, so they have another freedom. But how is it in France?
In Switzerland, everyone is responsible of his building, the engineer, so he can do what he wants. He has to make a note to prove its work, but you don't have a rules, and the responsibility is on the. He write that to the allowed construction paper in Switzerland. In France, is a kind of difference because we love the administration, the complication. They don't trust architects, and you have a lot of engineers who assurance work together. So and the rules are made by private group. So when the record is right by Vical, Lafarge, big concrete group, they told you have to put some concrete. That's the rules, and so you made the conception with an engineer. It's an engineer office. Then you present it at the controller office, and the controller office write something, say it's okay, they can build. And you don't have the state to control it. It's just a problem of assurance. It's a problem of money. That's just that.
Great. Thank you very much for your valuable informations and presentation. Thank you.
You're welcome.
So thanks. I don't know if there is any other question.
I think there are.
I have checked in the chat, but in general it is like this.
I had one question.
Yes.
In small houses, stone houses that you also showed your projects, implied projects, are you still using cement in the foundation? Or how you resolve the foundation in the small?
The foundation depends on the floor. In each project, in this project?
2 stories.
On each project we have different foundation because the floor work differently. I prefer the superficial foundation, but we tried on another project to have stone foundation too. Yes, with stone and some wood to connect them to don't have any movements. So you can do it, but and prove its work, But after, it is the workers, the builders, who don't want, they don't have the assurance to do it. After, it is just in France, la G1, G2, say you have to put your foundation at each, and it just a problem of cost. But each project here have it is not a villa pour Bernard Arnault. C'est tous, it's all project is for social housing or so I don't want to, I try to make the project work with the floor and with the foundation, and I try to don't put some money in the foundation. So I have some, I never work without the floor information, and the floor information can move to the project. If I have a very bad floor and I need to take some des pieux, je sais pas comment on dit des pieux. Pillar foundation, maybe I will take some arc on the first floor because I need to put on the particular point. And every project is just drawn by technical. I love aesthetic too. And never aesthetic, but I love aesthetical too. But our job for me, architect, is to work for the user and not for me. So my ego, my will, I try to put it on another way, or I try to make some paint or sculpture.
For every project, are you working with a different engineer, or there is always the same engineers that are put in stone?
Every project is different engineer. But I draw everything. I can read. I'm not an engineer, but I know how to read an engineer note. I draw the structure. I draw the economical. I am good engineer too, but they are here just to allow my draw. And when Gilles Perraudin said that, because he was high-tech before draw stone, and he worked with Peter Rice, a great engineer, and Peter Rice said when the note don't work, redefine the note, recalculez-le jusqu'à ce que ça marche, et ainsi de suite. En fait,
when it doesn't work, we just make the calculation again until it works.
Yes. Not enough. But we are not easy architects.
Okay, and I think there's a question by Zeynep Sema.
Yeah, hello. Thank you very much for your presentation. In your Geneva project, I think it was the social housing with a concrete floor. I have got a question about it. And you've said you avoid using the chains and you avoid also using the cement-based mortar as well. So I wondered something, while the floor meets the stone walls or anything,
this one
walls. Yeah, here. Do you use any material between concrete floor and the stone that just makes a barrier between these two, because you don't want them to just break each other, right?
Yeah, I know why one. No, you have nothing between the floor and the stone. On the last floor have some not chains, but some steel to grab the stone, because the stone, if you have an earthquake, don't have to fall.
Yeah.
Just the last.
Just on the last floor.
One. After it is the friction and the weight of the stone. Who did his aptitude.
Negligible?
Just
Negligible? Very little, you mean? The friction, so they don't need any.
Sorry.
The friction is enough because of the weight of the stone, so there is enough friction, so the stone will not move.
Yeah.
They will not fall.
Yeah, but the weight you have, I don't know how many tons, but that's why you can't move it.
Okay.
Not the last floor because you don't have any weight. So
yeah.
Grab it.
Yeah. Okay, thank you. Thank you very much.
These calculations, earthquake calculations, are made for which degree of earthquake?
I think we are in the biggest, the hardest zone in Europe. In Europe, in the Alps, it is zone 4. You don't have zone 5 in the Europe.
I can share a map. During you were speaking, I was making the map where as a project with the earthquake map, so I can show this. So like this.
For the Europe, the last one. So that I don't know the magnitude of the.
So here is the earthquake map. Can you see my screen?
Right now, yes.
So you can see the earthquake map of France and Europe. And the red colors are the highest, the more risky zone with the highest magnitude earthquake. So the zones where are the projects that were presented by Jean-Manuel are here. So the crosses. So this is where are all those buildings, and compared to, so it is high for Europe, but it is low for Turkey.
I think we are not red, we are orange.
Yeah, and in Turkey we are red, half of Turkey.
I don't know, but we are really a small map, and some really small area are in zone 4, and small area are in zone 3, and something like that.
Sure. No, you're right, but in general, the magnitude in Turkey is much higher than the possibilities in France.
Of course, but if I have to I think it is not a problem of the magnitude of the strong of the earthquake. If I think it is a problem of the highest of the building, because I think if I did this, I think I'm not an engineer, but I think if I did the same building, but you fall 3-4 floors and do just a small building, we have no problem. The problem is to build tower and something like that. With the investment, it's a stupidity to build tower in earthquake.
Yeah.
I think
talk about this after the earthquake. The main first statement was this: the story should be maximum 4 or 5 story.
Right, I think it's enough, but it's not a problem of density. I work. I love urban plan. I love work with that. The most density in France is not La Défense in Paris. It is an oldest in Lyon, an oldest quartier. Zone à la Croix-Rousse. In Pisé, in earth and in 5 floor. Le problème, c'est un problème après de monnaie. C'est another problem. I think.
It's also very nice to see that the social house buildings are made from stone. Okay, I understand you also can persuade the contractors, but still there is a vision or the municipality, or as I understand, I don't know, social offices, somehow there are fundings that could let you make a bit more healthier buildings, I can say, hopefully.
Yeah,
Nice.
well, it's social housing, I think, for me, but we don't talk about a square meter, but social housing a bit for one of my most beautiful experience is when I was in Lebanon, and I built in earth with Syrian refugees, and build in earth, and it's really more important than build a big, large stone building in Switzerland. My congratulations is bigger for this small building for people who need it than great building in Geneva in banks. But that's why I did this job.
We can understand.
Okay. So I think we are approaching to the end of the presentation of this discussion. It was really interesting discussion also to see how the same office can work both with stone and earth for different projects. And and Gilles Perraudin and I also know how to use those two materials for different projects in different contexts and adaptation to the context. So that's really interesting to see that both of them can be used by the same architects for different places. So thanks a lot for showing it. It's also very very good to see. As a personal note, I don't know any of the new project of Gilles Perraudin, but I have studied in Lyon in the School of Architecture. So I was in these buildings that I experienced this architecture by Gilles Perraudin before. So I'm sure the new buildings are as comfortable. So I'm very happy to see it's continuing.
We try.
Latest question. Could we reach some details, more details about the buildings in any kind of resource? Could you find easily the resources? I can check it before. That's why.
Yeah, you can check it. Every project are really published and on detail, the magazine detail, or you have a lot of publication. So every detail are on the internet, I think.
And I have the book in English about stone construction also.
Right. We will try a reedition because it is sold out with new projects. We try to put some detail on some, because we try to give to students, to architects, our work.
Thank you very much for your time, really.
You're welcome.
Thanks a lot for everything. And wish you a good evening or end of evening.
Yes, and also I would like to thank you especially Matthieu and Ant for this webinar series organization from beginning to the end, and very much Matthieu for his moderation most of the time. Thank you all for your participation.
Thanks a lot again. So
hopefully we will see each other.
See you. Yeah. Bye bye.
Okay.
Thank you.
Thank you.
Thank you very much. Bye bye.